I won't be able to switch to my video today. I'm not really feeling well, so can't help with that.
Yeah, I can hear you.
All right. Can you see my screen?
Yeah.
Okay. So, what about your school? I was looking at your topic 3 review PDF. I was looking at the review sheet for topic 3. How is topic 3 so far? How have you been working through it? Let me switch to the PDF here. Can you see the PDF?
Yeah.
All right. Just down. I'm not doing so well, so bear with the low voice and the low energy also. Okay. So
Why to class?
I'm not that sick either. It's just a bad cold and viral infection. It's just a seasonal thing. So yeah, a bit of lozenges and medicines is fine to keep going. And I felt bored, so I was like, why skip the class? What about you? How are you doing? Are you doing well?
Yeah, I'm doing good. Hope you get well though.
Yeah, it's going to be fine in a few days. I came back to Hyderabad from Delhi, so the change in city, the change in weather, so that's also another reason. But yeah. Okay, anyways, let's discuss a few things here in topic 3 so that we are matching the pace at school also. So right, last class, you did tell me that you were in 3.4, lesson 3.4, right?
Yeah.
And are you done with lesson 3.4 or
Wait. I mean 3 point. I said 3.2.
3.2? Oh, okay, sorry, 3.2. I remember 3.4. Okay, so 3.2. Are you done with 3.2 then? Or are you still working on 3.2 in school?
Uh, what? Say again?
Are you working on 3.2 in school or have you moved on to 3.3?
We are doing 3.2.
3.3, 3.2. Okay. And how has it been so far? Any major confusion in this topic about what you are trying to study? Because this particular topic seems like a big leap from what you were studying in polynomials. A lot of calculations, a lot of information to do with here, to work with here. So how is it so far? If you have any specific doubts or any specific confusion about why are we how did we get to this particular topic from polynomials? We were studying just equations. Here we are starting to work with graphs. So if there is any such confusion, do let me know. We will take that up. Okay. And is there a lag between my voice and is there anything laggy today, or is it
Not
fine?
really.
No? All right. So, okay. So, do let me know then. I felt that you were
Other
experiencing some
question.
lag. Yeah. Any questions?
Wait,
And
repeat the question.
I was asking that topic 2 was polynomials and factoring, right? We did not really have much to do there apart from, menial calculations and calculations generally. In general, we were working with calculations. And topic 3 and topic 3 is very topic 3 has a lot to do with graphs here, right? We have a lot of graphs and a lot of practical applications also. So is there any major confusion in this topic regarding why are we doing this or why are we studying these things, or any major problem? Let me know in general. In short, let me know if there are any major confusions about what we are studying here.
Not really.
Okay. All right, then let's complete topic 2 then. From topic 2, Are there any doubts in topic 2 from where we left yesterday? In the last class, you were supposed to complete these questions. Question number 25, I think, and 20. I think I also gave you, yeah, 25. Did you do this question? Question number 25?
I did, but let me see if I have it in my notebook.
Go ahead.
Can't remember which notebook.
No worries. If you can't find it, let it be.
No, wait. No, I can't find it.
All right, no worries. What about difference of two squares and this particular problem? If I ask you to solve this problem for me, 1.5, question number 25, quickly tell me the answer for it. If you cannot, then let us discuss the formula or the difference of two squares, this particular thing.
Okay. Wait, can you show the question?
Question number 25.
They can show it.
You can't see my screen you can't see this
No,
PDF.
wait, now I can. Now I can.
Okay. Question number 25, the one underlined with blue color.
Okay, okay. Is it 2.25x minus 4?
2.5,
25
25. Okay.
x plus minus 4.
25x minus 4. That's your answer. 25x square minus
No, I
4.
mean 2.25x minus 4.
2.25. Okay.
X minus 4.
Okay, so there's 25 and then there's also 2.5. Is this the
Yeah.
answer? Okay. Okay,
Wait.
so
No, wait. Can I just write it?
you can just spell it out for me once again. It is
2.25 x.
okay,
Yeah.
2.25. Okay. You should that's actually read at 2.25. But yeah, still you were right. I misinterpreted it. Okay. Okay, that's 1.5. Yeah, that's right. That's right. So basically that's this particular identity or the difference of two squares. Okay. This particular thing a plus b into a minus b. If you have a binomial which differs with only a plus and minus sign with a plus and minus sign, then the answer would be a squared minus b squared. Okay, so you would substitute a and b for these values and you will get the answer, right? So this is one of the special cases. And then throughout this exercise or throughout this particular thing, the one thing that I would want you to get across, uh, can I work with this? Oh, yeah, say eraser. Yeah. In the last class, you were sort of confused with this thing, right? How to distribute a binomial over a trinomial, right? We were working with this particular thing where we had, let's say, let's take this trinomial 12x squared minus 47x plus 45. And let's say we are multiplying it with 3x minus 1. In the last class, you were confused with this particular thing, that how do we distribute this binomial over this trinomial, right? Is that confusion cleared now, or do we have to go over it, or do you want me to go over it again? Ibrahim, are you here with
Okay.
me? Do you want me to
Yeah.
go over it? The
Yeah.
binomial distribution? Okay, let's get that done once again. Okay, we have this with us here also. Okay, see, this whole exercise and the way your school is trying to teach you or make you understand how to multiply, binomials or trinomials. The one thing that you need to very simply understand in this whole topic is, we had that we had 12x squared plus 47x, 12x plus 45 minus plus 45 into 3x minus 1. Okay, on one hand we have this with us, and on the other hand we have this with us here. In the last class, this particular thing, 3x minus 1 whole cube, uh, arose from this particular thing. We have a cube with us, right? We had a cube with us yesterday, and we were supposed to find the volume of this cube, and we were given one side of this cube was as this particular value 3x minus 1, and volume of cube was asked volume of cube. So volume of cube is basically the cube of the side, right? And the side here is 3x minus 1, right? In the last class, you were confused between this particular thing, that how do we get the cube value of this particular equation, right? So in the last class, we worked on this thing, that 3x minus 1 whole cube would be nothing but 3x minus 1 into 3x minus 1 into 3x minus 1. Upon multiplying 3x minus 1, you would get a binomial. You knew how to distribute a binomial over a binomial up until now. And upon distributing the binomial, we got this particular trinomial, right? 9x squared minus 6x plus 1 into 3x minus 1. Right now, in the last class also you faced this confusion with this particular thing, how to distribute a binomial. So in short, it is very simply this thing. We would distribute this whole 3x over this whole trinomial. Okay, we would multiply, basically, instead of using the term distribution, I believe using the word multiplying 3x to all the terms in this particular trinomial is the first step. So basically 12x minus, this would be the first one, and then this one would be multiplied across these terms. Doesn't matter if we had 3 terms here or 4 terms here. The general rule or the general idea is basically multiplying this -1 to this -1 across all the terms in this particular term when we are multiplying this. Okay, it's basically asking someone or understanding in your early classes or your preschool, that if we had 4 plus 7 plus 8 into 5 plus 3 plus 8, if we had this, how would we multiply things, right? Back then it was simple. We would just add them and multiply them, or we can add these values and then multiply them together, or we could, also do one of
Okay.
those things, right? So here we are trying to abstract those concepts and apply them, right? So when we are multiplying this, we can either do this thing 3x minus 1. We can choose this particular binomial and choose to do this. Doing this would reduce the number of steps. You could do this other way too. This is the easiest way to do this. Yesterday, you were in the last class, you were looking out for easier ways to do this. Instead of, distributing the binomial over a trinomial, we are distributing binomial over a trinomial. All right. We could also distribute
Okay.
trinomial over a binomial. Okay. This would be a little lengthy in terms of looking at it, but it's the same thing again. What you could do is 12x um, into 3x minus 1. You could do this, and then minus 47x into 3x minus 1, and then plus 45 into 3x minus 1. Okay. This is distributing a binomial over a trinomial over a binomial, and this is this. Okay, both the things will end up at the same result, but these are the two ways you can do it. Okay, this might seem easy, this might seem easy, depends on your perspective, but the both of these things will result in the same answer at the end. Okay, so if we look at this thing 12x, if we look at this particular value, this one, let us see, that would give us 36x squared x cube minus 12x square, right? And then this would give you 3 4s are 12, 141 x squared minus 47 plus 47x plus 3 5s are 15 and 3 1s are 3 4s are 12, 135 minus 45, right? So upon adding your like terms here, you would have 36x cube minus uh, minus 12 and minus 141 would give us 153 x squared and plus 47x, and then this would give us 135 minus 45. So 13 minus 5 is 13 minus 4 is 90. This would give us plus 90, right? So this is our equation. Now if we look at distributing this particular thing and look at the answer, we would get the same thing again here. So if we do that, we would get 36x cube minus 1 321 3 4s are 12 141 x square plus 3 5s is 15 and 135x minus 12x square plus 47x minus 45. Okay, so if you add these again, you will get the same thing. So this would give you 153x square plus 47x, not 47x, we missing something here. We have an extra 47x. Okay, we did not add this here. We made a mistake here. 47. Yeah, I did not write an X here. Sorry. Instead of here, it would be 45 into 3x would give us 135x. So 135x minus 45. So the answer would be 36x cube minus 153x square plus 135 plus 47 would give us 12 182x, 182x minus 45. So 135x minus 45. So okay, both the answers are same. Distributing a binomial over a trinomial is also going to give you the same thing. And then doing it the other way around also is going to give you the same thing. Okay, depends how you want to do it. And this also shows you that there is not a set way to do things. You are not necessarily supposed to distribute a binomial over a trinomial or a trinomial over a binomial. Okay, and over here now you can understand this, that you can do it either in 9x squared into 3x minus 1 minus 6x into 3x minus 1 plus 1 into 3x minus 1 this way, or you could do it either 9x squared minus 6x plus 1 into 3x minus 1 into 9x squared minus 6x plus 1. Both of these will give you the same answer, right? Any doubts in this now? Yep, Ibrahim. Hmm. Did I just speak to myself? How are you listening? Are you listening? Hello, Ibrahim. Hmm.
I was muted. Actually, my bad. I actually have a question.
Okay, go ahead.
When you have you found 36 minus 150x square plus 182 square minus 45.
Mm-hmm.
If 36x is the power of 2, we are still simplified, right?
Uh, Let me, number these steps. This is step 1. This is step 2. This is 3, and this is 4. And in this particular step, this is step. Let me name this as step A. This is B, and this is C. In which particular step are we talking about? Are you looking at?
The last step. I'm just saying, for example, if 36x to the power of 3 became 36x to the power of 2, that means we will have to do 36 minus 153, right? Because they're
Yep,
both
yes,
similar.
we will simplify terms until we have like terms. We will leave only one term from each particular, variable, each particular power. A term with x cube, a term with x square, a term with x, and then a term which has no value of x to the power 0, a term which has x to the power 0. So we will simplify the terms and terms until we have only one of each, x cube, x square, and x to the power 0, x to the power 1. Until
Okay.
we have one of each, we would simplify them. We will add the like terms, subtract the like terms, whatever the sign is given to us. Until then, we would, simplify them, collect them together, subtract them. All right, we would do that definitely. Okay. And continuing over this, any other doubts on this?
Yeah.
Other doubt? Okay, go ahead. That's it. That's the doubt, or is there any other?
Yeah. That's all. That's all.
That's all. Okay. So after this, we have multiplying special cases. Multiplying special cases, and in special cases, we are being told that multiplying two binomials, multiplying two binomials would always result in this particular pattern here. They are calling it a pattern, that if you multiply two positive binomials, then you would get a square plus 2ab plus b square. And then if you have a binomial of this pattern, a plus b into a minus b, this would give you a square minus b squared. Okay, so basically if you have something like 2x minus 1 into 2x plus 1, you would simply call this term a. You would simply compare these terms. All right, and then you would simply substitute them over here. 2x squared minus 1 whole squared. Okay, if you had something like, let's say, 2x minus 3 into 2x minus 3, 2x plus 3, you would simply substitute 2x whole square minus 3 whole square. If you had, yeah, that's the point here. These are two, this is the topic in topic 2.3, lesson 2.3. 2.3. This is the special cases that this particular thing talks about, or basically what they're trying to get across is that if you have something like this, a plus b into a plus b, this would be a plus b whole squared, right? So instead of always multiplying a into this and then b into this and b into this and then writing a square plus 2ab plus b squared, they are simply telling us that if you have something like this where you are multiplying two like binomials, then simply put in the terms in this particular pattern. You know, if you had this a question there, b plus 12 into b plus 12. Now b plus 12 into b plus 12 is b plus 12 whole square, right? So instead of multiplying this and this and this and this again and again, you can simply remember this pattern, a square plus 2ab plus b square, and you can simply substitute the values here of a and b. Okay, b squared plus 24 into b plus 144. Okay, so instead of doing this, you can either remember this formula, okay, or you can either work your way through step 1, 2, 3, and 4. You can do either of them. Okay, and then again there is one other case. If you have a minus b into a minus b, you would have a square minus 2ab plus b square. Now you can come to this point, come to this pattern by multiplying this and this and this. So this is going to be step 1, 2, 3, and 4. So if you look at that, then step 1 would be a square minus ab. This is 1, this is 2, and then ba is 3, and then minus into minus b would become my plus b whole square. This would be 4. So this would give you minus 2ab plus b square. Okay, so basically what we worked over here, understanding, trying to multiply a binomial over a binomial and a trinomial, we are just trying to generalize how we would be multiplying, such binomials where we have letters instead of numbers. Okay, so these are the three
Mm-hmm.
special cases that we have in topic lesson 2.3. Okay, so let us just take a quick example again. If we have 3x minus 4y into 3x plus 4y, what would be the answer? This is of the form a minus b into a plus b. So this would be a squared minus b squared, right? So what would be the answer here? If you substitute, if a is 3x and b is 4y, a is 3x and b is 4y, what would be the answer?
No, 9x square, right?
Yep, 9x squared minus
Uh, 16, uh, 16, yeah, y
si-
square.
16y square. Yep, exactly. Now instead of 3x minus 4y into 3x plus 4y, we had this. Then the answer would be, then this is of the form a minus b into a minus b. So this would become a minus b whole square, and this is of this form. So then the answer would be, then the answer would be, this is your a and this is your b, right? 4y is your whole b. Then the answer would be, you would have 9x square and plus 16y square, and then in the middle you would have 2 times a into b. What is a and what is b? A is 3x and b is 4y, right? So 3x into 4y, what will this be?
3x into 4y.
Yep.
That would be 12 xy square.
12xy, that's it. This is what to the power 1, this is to the power 1. So this would be x to the power 1 and y to the power 1, right? So it would just be 12xy, 12xy. And then you can also simplify it a little further. You can write 24xy, right? Can we do that?
Yeah.
Yep. So the answer would be in a much coherent way, 24xy, right? Now, if I had 3xy plus 4y into 3xy plus 4y, right? So this is of the form 3x plus 4y whole squared. So if we have a plus b whole square, the pattern would be a square plus 2ab plus b square. So what would be the answer here?
2x2 square a square minus plus 2ab plus 2b plus b2.
Okay, that sounded that sounded very confusing. Repeat it once again.
Can you ask the question again? I didn't hear that much.
If we have this with us here, 3x plus 4y into 3x plus 4y, which becomes 3x plus 4y whole square.
Yeah.
And 3x plus 4y whole square is of the form a plus b whole square, right? And upon expanding or upon, simplifying it, we would have a
So
square plane.
it will be
Yeah,
3x square. No, sorry, it will be 9x square plus 16 ab. No,
not 16.
12ab.
12ab is going to get multiplied with 2 also, right? So that would
Ah,
be
yeah. So it will be 24ab.
plus 24ab,
Plus
24xy, 24xy
plus 4 times 4, 16 b2,
16y
b
square,
16 2. Yeah.
16y to the power 2. All right. So this is going to be the answer. Okay. So if I have something like this, we have a question from your book, from the review topic. If we have this mx squared, m into x whole square is equal to 5x plus 8 into 5x minus 8. What would m be here?
M.
Yep. What would m be here if you compare it? This is a plus b into a minus b, right? And this is a square minus b square. So your x, a is this, b is this. Yep, a is 5x and b is 8. So mx square, meaning this m would be, if you compare it, mx square would be equal to 5x whole square, right? And if you compare this whole term here, right, a is equals to 5x, b is equals to 8. So if I substitute mx squared is equals to a square, and then 64 is equals to b square. So I have a as this, and then now if I compare, mx squared is equals to 25x square, and then 64 is equals to 64. So m would be 25. Does that make sense?
Yeah, a little bit.
Yeah, we are basically comparing the terms. How did we get to mx square minus 64? We got there from this particular binomial 5x plus 8 into 5x minus 8. This is of the form a plus b into a minus b, which gives us a square minus b squared, right? And we compare the values of a square minus b square, where a is 5x, b is 8. We could come up with I could make up an example for you again over here. Let us say we were working with 3x minus 4y, right? Let us say we had 3x minus 4y and 3x plus 4y. Now we know that this is of the form a minus b into a plus b. So this would be a square minus b square. Now to make up this question again here, I would say that mx square minus 16. Now what is m here? right? Now what is m here? You would what you would do here is write that a is 3x and b is 4. So when you have mx square minus 16 equals to a square minus b square, you would compare these two terms. You would compare instead
Yeah.
of this, mx square is equals to a and b square is equals to b square, right? So what we have a as here 3x, that implies mx squared is equals to 3x whole square, and b square is 16 and 4 whole square. So that implies m square, mx square is equals to 9x square and 16 is equals to 16. So our m is 9. Okay, you can come up with many more examples like these on your own also. This is just to make you understand how things work. Okay, what's the date today? The date is 18th October, right? So if we have, let's say 18 is made up of 9 into 2. Okay, let us use this 9x minus 2 into 9x plus 2. This is a minus b and this is a plus b, right? This is a squared minus b squared. So the answer would be 81, 81x square minus 4, right? This would be the answer. Now you could make up the puzzle here that what would be this? This would be this and would be 81, or else you can say that 81 minus m, this would be m, let's say, then this would be this. Basically remembering this particular identity or pattern, however you would want to associate it with, okay, whichever word. So this would be your multiplying special cases. Okay, any doubts on this?
Um, Not really. No.
Now you just need to understand these things. A plus b into a plus b is a plus b whole square. Now you could either remember these formulas or you can work on them manually each and every time. Okay, and then a plus b into a minus b is equals to a square minus b square. Okay, all right. So these are the three special cases that you will be using in this. Okay, now let's move on to factoring polynomials. Okay, factoring polynomials is everything that you did with greatest common factor or highest common factor. Do you remember the concept of highest common factor?
Yeah.
If we have, let's say, three numbers 16, 8 and 4, to find the greatest common factor of these three numbers, what you would do, the first step would be to write the prime factors of 16, to split 16 into its prime factors. That would be 2 into 2 into 2, right? And then 8 would be 2 into 2 into 2, and then 4 would be 2 into 2. So now the greatest common factor or the highest common factor for these three numbers is going to be 4, right? The greatest, the number, the highest number of times 2 is repeating in all of these three numbers, in the factors of these three numbers, is 2 squared, right? 2 into 2 times, which is 4. So 4 is the greatest common factor, highest common factor of 16, 8 and 4, right? This concept is clear for you,
Yeah.
right? Now this is for numbers. Now if we have x squared, x to the power 4, let's say x to the power 6, x to the power 6, x to the power 4 and x to the power 3, right? To now find the greatest common factor of these three, GCF
Sneeze.
or HCF of these three. Now we do not really know what x to the power 6 is, but we can of course say that x to the power 6 is a multiple of 6x's, right? 1,
Yeah.
2, 3, 4, 5 and 6, right? And then x to the power 4 is a multiple product of 4x's, right? And then x to the power 3 or x cube is a product of 3x's, right? So what you can
Yeah.
say now is that the greatest common factor, highest common factor of these three numbers or these three variables is going to be x cube, right? This is going to be our highest common factor for these three variables, x cube, right? Does that make sense?
Yeah.
Okay, so now if we have something like 16x to the power 6 minus 8x to the power 4 plus 4x to the power 3. Now to club these two things now and to say the highest common factor or greatest common factor, GCF, HCF of this particular polynomial, okay, this particular trinomial. Now you can say that since 16, 8 and 4, the greatest common factor of 16, 8 and 4 was 4. That is what we found. And then the greatest common factor of x to the power 6, x to the power 4 and x to the power 3 is x to the power 3, right? So when we remove these things from 16, if I remove 4 from 16, I would be left with 4. So I would write 4. If I remove 3 x to the power 3 from x to the power 6, I would be left with x to the power 3, right? And then if I remove 4 from 8, then I would be left with 2. So I would be left with minus 2 here. And then I would be left with 1x here. If I remove x to the power 3 from x to the power 4, so that would give me this. And then 4x cube is quite literally removing the whole thing from this. If you are removing 4 from 4x from 4, I would be left with 1, right? 1. And then if I remove x cube from this, then I would be left with 1, right, into 1. So
Yeah.
I would have this with me, right? Now if I multiply 4x cube into the trinomial again, this monomial into this trinomial, I would have 16x to the power 6, right? Then 4x cube into minus 2x would give me 8x to the power 4, and then 4x. Oh, sorry, this was plus. Sorry. So this would be what we had again, right? So factoring polynomials, or finding factors of a polynomials works in this manner. Okay, you would work on the numbers individually, you would work on the numbers in one set and the variables on in the other set. Okay, any doubt in this thing?
Mm, not really, no.
No. Okay, let us move to, let's take an example. Okay, from your 12a cube plus 18a square minus 36. Okay, now if someone asks us GCF or HCF of this particular thing, so what would we do? First of all, we would look at the numbers individually, right? And then the variables individually, right? So what would be
Yeah.
the prime factorization or the prime factors? If I write 12 in the terms of its prime factors, what would be the prime factorization for 12? What is 12? How is 12 written as? 12 is a product of 3 into 4. You can proceed from there. Then 4 can be split
Yeah.
into 3 into 2 into 2. You can proceed in this way. Okay, think of
1 times
whatever.
12.
Yep, 3 into 2 into 2 is the prime factorization of 12, right? Or else you can also proceed from 6 into 2. Then you would write split 6 into 3 into 2. Okay, just try to remember the closest whatever, like remember the multiple of that number in whichever way you want to, and then split it into its prime factors. Now 18 is, you can write 18 as 6 into 3 or 9 into 2. Both of these will give you 3 into 2 into 3 or 3 into 3 into 2. The same thing, right? You have no problem in splitting numbers into their prime factors, right?
Yeah.
All right. This is a little bit of elementary mathematics, so bear with me. We will get done with this. What would be for 36? Tell me for 36.
36, we can do wait, 6 and 6.
Yep. Okay. And then that would be 3 into 2 into 3 into 2, right?
Yeah.
So if we rearrange these into a little bit of coherence, let us write it 3 into 2 into 2. 3 twos are 6, 6 twos are not 6 twos are. This is 3 into 3 into 2, and then this is going to be 3 into 3 into 2 into 2. So the greatest common factor that is repeating in all of these is 6. That is
Yeah.
3 into 2. So this would be 6 for this. Greatest common factor for these three numbers is going to be 6. And for this particular thing, a cube is a product of 3a's, a square is a product of 2a's, and a is a product of a into 1. So what is the greatest common factor in these three? A, right? So
Yeah.
6a is going to be the greatest common factor that we will be looking at, right? So if I take out 6 from 12, that would leave me with 2. 6a is going to be taken out. So if I take out 6 from 12, I would be left with 2. And if I take out a from a squared, I would be left with, if I take out a from a cube, I would be left with a square. If I remove this, I would be left with a square. Plus, if I take out 3 into 2 from this, I would be left with 3. So 3 and then a single a, minus, if I take out 3 into 2, I would be left with 6. And then if I take out a, then I would be left with 1. So the greatest common factor, or the factorization of 12a cube plus 18a square minus 36a is going to be this. And you can cross verify it or verify it again by multiplying 6a into the number. If I multiply 6a into this, or distribute the monomial over trinomial, I would get 12a
I'm
cube,
listening.
and this would give us, did you say something? 36a. Okay. 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 Pay attention to while you're listening to me. Okay.
Okay.
Okay. So do you get the hang of it? What we are trying to do here?
Yeah.
Okay. So let us move to the book here. Let me switch to the PDF.
Okay.
Okay. Can you see the PDF here?
Now, yeah.
Yep. So as you can see, everything that we discussed so far is was from this particular section, factoring the polynomials, and then we also got done with lesson 2.3. You know, we did this, and then we did a few other questions. We did this. Okay, so your homework would be from these two lessons. Okay, lesson 2.3 and 2.4. All right.
Okay.
And I think we will end the class here for now. If you have any doubts, let's take them in the next class based on the homework. Okay.
Okay.
And we would be left with two lessons, not two, 3 lessons, 2.5, 6, and 7. Okay. All right. Okay. You won't be going to school on Sunday, right? You would have a holiday on Sunday.
No, I go to school at Sunday.
Okay, you have a holiday on Friday then. That's it.
Yeah.
Oh, okay. All right then. No worries. I will update the homework on the portal. So go through it. Don't forget to go over the homework, or let me take you down. Let me just give you the homework here and then upload it on the portal also. So that you don't really have to go to the portal and check it. But you will have to upload on the portal also, right?
Yeah.
You're supposed to upload your homeworks there. So do keep a track of your notebook, whichever one you're using. Okay. Okay, so from lesson 2.3, you would be work on 28, work on 28, work on 23. Okay. And then from 2.4, work on 36. And work on 36, work on 34, and the whole of, you know, just
Yeah,
find the GCF of each group. Did you make a note of that? Make a note of
yeah.
these questions. Okay. I will upload them on the portal also. So the academic team will get in touch with you if you do